Okay, let's take a peek at this review sheet here from Math 1, and there's a couple concepts we're going to be going through. First one is saying, let's go over some means. We're going to talk about arithmetic sequence means and geometric sequence, one being when we're adding and subtracting, one being when we're multiplying. So when you're looking at these, we're basically looking to fill in the blanks here. And once you find the pattern, that's great. So to jump from 5 to the unknown again to the 23, you could pick a number like a guess and check and see if it works and adjust. But there actually is a formula that hopefully you were exposed to in Math 1. And if not, we're going to learn it now, where you can see what that number is right away. So for example, we can see that we're trying to end at our result here of 23. So we're going to say to get 23, we are starting with 5 and we're adding some number repeatedly, and we're jumping, check this out, 1, 2, 3 times. So the 5 comes from where we're starting. The 3 jumps comes from counting, like not how many spaces there are, but how many times I would jump, 1, 2, 3 to get to that 23. And this unknown, this D, is going to stand for the common difference that we're trying to find. So I'm going to solve this backwards. I'm going to go minusing 5 from both sides. 23 minus 5 is going to give us 18. And then we divide both sides by 3. So my common difference is 6. So 5 plus 6 is 11. 11 plus 6 is 17. 17 plus 6 does give me 23, so good job. 23 plus 6 is 29. 29 plus 6 is 35. 35 plus 6 is 41. So do you see how first we can rely on this formula, get that common difference, and then apply it to fill in the blanks and continue the pattern? So let's go try the next one using the same method. So we're going to end up at 38. We know to get that 38, we're starting at this negative 10, and we're adding something repeatedly 1, 2, 3, 4 times. There's 4 jumps this time. So here I go, solving this equation, plus 10 to both sides. That's going to leave me 48. And then we divide. So this time our common difference is 12. So we say negative 10 plus 12, use a calculator if you need to, is 2. 2 plus 12, 14 plus 12, 26 plus 12 does give me 38. 38 plus 12 gives me 50. Now to go back a step, imagine that you're saying to yourself, what plus 12 would give me this negative 10? So we're going further into the negative. So picture this, negative 22 plus 12 would give me that negative 10. Again, use a calculator if that was confusing to you and you need to see it. Okay, pause the video here and try part C on your own using these 2 examples, and let's see how you did. Okay, let's try it. How'd you do? To get that negative 13, we start with 27 and we're jumping 1, 2, 3, 4, 5 times. 5 times that common difference. So we subtract 27. We're going to get negative 40. Do that on a calculator if you need to. And then divide by 5. This time, notice that negative, the common difference is negative 8. Means we're subtracting by 8. So 27 minus 8, 19. 19 minus 8 is 11. 11 minus 8 is 3. 3 minus 8 is negative 5. Negative 5 minus 8 is negative 13. That makes sense. To go back a step, the 27, what number minus 8 would equal 27? So it's like we're adding 8. And we would go 35. 35 minus 8 would give us 27. Use a calculator if you need to confirm that. How'd you do pausing the video and trying that one on your own? Did you get the negative? So that's the arithmetic mean. We're finding the arithmetic mean. I want to write that over here. And that just means we're finding those missing spots in the middle of 2 numbers given to us in the table. and then we continue the pattern where necessary above or below. So in these next three, we're going to be looking for the geometric mean. So instead of adding or subtracting this time, we're going to be multiplying. So let's go check out this one and see what that formula looks like. So for the geometric mean, the formula is very similar. We're ending at 250. We notice that this time it's a jump of 1, 2 times. So this 250 starts with 10 and then is doing a jump of 2 times. So it begins with 10 times 2. Well, we don't do times 2. We don't know the multiplier and what it's going to be. So that's our unknown r. And the 2 jumps this time, the repeated multiplication is actually going to show up as an exponent. So a little power of 2. So hang on a second. I'm going to start this one over again and show you how we built that equation one more time. So this time we're landing at 250. We know that the 250 has to be that starting number 10 multiplied by some unknown common ratio. We're going to use r. How many times are we doing that? 1, 2 jumps. So how does that show up in this one? It's going to be an r squared. It's the exponent that gets those 2 jumps. So we're trying to find this common ratio. Let's do some work. First, we're going to divide both sides by 10. We're going to see that our r squared is then equal to 25. And so how do I undo an r squared to solve for r? I'm going to square root both sides and get that my common ratio is equal to 5. So let's go test it out. 5 as the multiplier. 10 times 5 is 50. 50 times 5 is, yay, 250. So that worked. Now grab your calculator because this is going to get really big. So 250 times 5, I'm getting 1250. 1250 times 5, grab your calculator. I'm getting 6250. 62 times 5, one more time, 31,250. Now to go backwards, instead of multiplying by 5 to go down to all these bigger numbers, we're going to go divide by 5. So that starting number would be 2. 2 times 5 makes 10. 10 times 5 makes 50. 50 times 5 makes 250, and so on and so forth. We fill that in down. Okay, so let's go check out another one using this same formula building. This time we're going to be landing at a 192. So to get this 192, we know it begins with a 3 and is multiplying by some unknown common ratio r. How many times? 1, 2, 3. Power of 3 times this time. So here we go. Let's do some work on this little equation. We're going to get that r cubed is equal to 192 divided by 3, or 64. How do I undo an r cubed in an equation? I'm going to cube root it. So the cubed root of 64, what number times itself again? Is 4, meaning 4 times 4 times 4 is 64. That's my r cubed. So if my multiplier, my common ratio is a 4, let's go fill in the blanks and see how it looks. 3 times 4 is 12. 12 times 4, 48. 48 times 4, grab a calculator and test it out. Yes, it gives us 192. 192 times 4, you got it, 768. 768 times 4, 3072. Now to go backwards from the 3, instead of multiplying by 4, we're going to divide by 4. So here you'd write 3/4 or 0.75, whatever you're comfortable with. All right, pause the video and see how it works on this last one, and let's see how you did. Okay, so this one we're going to end up at 1458 after we begin with 18. Multiply it by some ratio r, 1, 2, 3, 4 times. So r to the 4th. So here we go, divide that by 18. Grab your calculators. I'm getting 81 is equal to r to the 4th. So picture it, right? R squared would be 9. So we're splitting up that 9 even further. We're going to get 3. How would I undo an R to the 4th on a calculator? You would take the 4th root of both sides, and that gives us 3. What that means is 3 to the power of 4 is 81. Meaning 3 times 3 times 3 times 3. Do you see that 9 times 9 embedded in there? There's our 81. So if my multiplier is 3, grab your calculator. You go 18 times 3, 54. 54 times 3, 162. Grab your calculators and do it again. 162 times 3, 486. And then test it out on the last one. Yay, it gives us 1458. To go back a couple steps, instead of multiplying by 3, we are going to divide by 3. So 18 divided by 3 is 6. 6 divided by 3 is 2. Okay, how'd you do on those? Remember that if you feel like you need more practice on these, we have this math website for our school that goes over Math 1 concepts, and you can go find videos here that go over these different concepts. So if you see right here this video on arithmetic and geometric means, that would give you more practice on the same topic that we're doing right now. You could take additional notes on it if you feel like you need it. Okay, so I'm going to pause the video here now. This was just the video on the top section for arithmetic and geometric means, and I'll start a new video for the bottom section in a second.